Hi, in this video, I'm going to introduce you to DAOstack, an operating system for collective intelligence. We will cover why we built DAOstack and why you should use DAOstack, how our stack works, and an intro for the toolbox for hackers. So, why DAO? To answer that question, let's first acknowledge that our current governance systems have a problem. Our current organizational structures does not have the capacity to cater to the problems that require large-scale coordination, such as shared economy or global problems like climate change. Hence, we need something better. We need DAOs, organizations tailor-made for the age of information revolution. But wait, what is a DAO? A DAO is a decentralized autonomous organization, an organization that is not owned by anyone but collectively managed by the people involved. An organization that is adaptable. It adapts to the fast changing times to solve the new problems. An organization that is able to run at a global scale without losing the decentralization, that is scalable. And lastly, an organization that is resilient and is able to recover from the attacks while maintaining all the above qualities. Well, thanks to the blockchain with global consensus mechanism, with which now humans are able to collaborate and coordinate at a scale that has never been possible in the history. It's so amazing to think about that the time to reach a consensus while being scattered all over the planet is just 15 seconds. So, why DAOstack? Well, at DAOstack, we want anyone to be able to launch their own DAO while having full control over the structural elements of the organization. Hence, we built a stack that is modular, which means our governance structure is made of small building blocks that can be combined easily or edited or removed. Hence, no redeployment required, thus saving the storage and operational cost. It also enhances the security by reducing the attack surfaces. The stack is also adaptive, so as the new modules get deployed to the blockchain by either third parties or the open source developers or by our team, the DAO can use these new templates without the need to redeploy the DAO. And upgradability. Each DAO created through Arc comes with a particular set of rules, which by default include the rules to upgrade or change these rules. Hence, all DAOs are upgradable. And lastly, scalable. The DAOstack DAOs use holographic consensus to achieve scalability. So, as the activity on DAO grows, the network of predictors, which is formed by the GEN token economy, use their GEN tokens to stake on the proposals that they think are worth passing, and thus brings those proposals to the attention of voters. And then these proposals can also be passed by relative majority. Thus, we are able to operate at scale. So, about our stack. The base layer of our stack is infra, which consists of building blocks of governance modules. Anyone who doesn't want to use the entire stack can still use modules from infra layer, such as voting machine or reputation in their contract, and built on top of it. The next layer is Arc, which is a smart contract library to create and manage DAOs. We'll discuss about it shortly. Archive is DAO's shared registries, basically to curate the list of DAOs. These all these three layers are at still blockchain level. On top of the blockchain sits the caching or indexing layer, which is a wrapper around the Arc blockchain state. It allows us to quickly read the blockchain data or write to the blockchain and change its state. And on the top is our API layer to interact with the subgraph and Arc. Client is a JavaScript library which performs read via caching layer and interacts directly with Arc to write to the blockchain. And finally is our app or dApp layer, which is the user interface. So we see infra, the basic building blocks of governance. Arc is a modular smart contract library. It can be extended or inherited from. This is the basic structure of a DAO deployed using the Arc layer. We have a set of schemes which contain the logic describing the actions a DAO can take. Example, a funding scheme can be used for distributing DAO's funds automatically when the proposal passes, and so on. Then we have global constraints, which are the conditions that must hold true at all times, and it can prevent the actions being taken if there is a violation. For example, you can think of an is human contract where people who are verified humans can register, and then a DAO can make sure it only whitelist those accounts to enter, to make a proposal to the DAO or vote in a DAO. And then we have voting machine, which is a pluggable component, and it can be used by schemes to manage voting process. It maintains a voting process and the proposal state and determines the winning outcome. It also uses the logic from infra layer, where we have the Genesis protocol logic. Genesis protocol allows the gen token holders to stake on the proposals worth being brought to the attention of the DAO, and Genesis protocol also allows a flow of reputation. Finally, we have a controller, which is an access control module. It keeps record of all the registered schemes and the constraints for the DAO. It also has the registry, which have the registry for token address and the reputation address and the DAO avatar's address. So our actors are token, which is very simple, ERC20 token. It is native to the DAO and can be used in DICO or like an equity in the DAO and so on. Then we have a native reputation in the DAO, which is very similar to the ERC token, same here, but different in the sense it is non-transferable, and also it can be awarded or taken back by the DAO as the need is required. Then we have a DAO avatar, which is the face of the organization. It holds all the funds and all the actions that are taken, depending on the scheme, are basically signed off by the avatar contract. Lastly, our cache, which is a service which sits outside the blockchain, and it enables fast read access by indexing all the events and allow us to use complex GraphQL queries to get the data. So finally, this is how different layers of the stack interact. At top, we have a dApp, which is running on a Web3 enabled browser and uses MetaMask or maybe Status to inject Web3 to the client library. The client library then has the right functionality and interacts directly with the Arc layer, which is on the Ethereum blockchain, to either create a new proposal or vote on the existing proposal, basically writes onto the blockchain. Blockchain emits the events which are indexed by our caching layer, and then the client library uses its read functionality and interacts with the subgraph layer to read the data via GraphQL queries, such as like current proposals and its name and the time it was created at, and so on. And let's present our hacker kit. By the way, at ETH India, we are offering up to $3,000 in prizes to the teams who build compelling projects on DAOstack. Alright, let's dive in our hacker kit.